All right. Well, how's everybody doing tonight? Did you have hopefully a good Labor Day weekend with your family? And looks like everybody that's here checked in. Cool. Yeah, I had a number of apps I was looking at to do this, and I didn't like any of them, so I made my own iPad app over the weekend. So I'm having some faculty debug it with me, but I got it to where it's creating QR codes, has a database in it for reports, it connects to Dropbox. The next thing I want to add to it is being able to email reports and create PDFs. So anyway, and it's going to be actually used eventually for not just anything with, it'll basically be, I'm using it for college right now, but it could be used for any type of conference or meetings. So if anybody has an iPad and you want to test it with me, you could definitely be more than welcome to do that. So if you have an iPad and you want to play with it and give me feedback, see me before you leave class tonight, and I'll tell you how you can get access to it and download it onto your iPad. Okay, so chapter 2, make sure here and right one. Chapter 3. Chapter 3, we're going to be, I think I told you last week, since we're not meeting Tuesday, we're going to go right to the in-class lab, but you do still have the review questions and quiz for this week. Do this for me too before I forget. In the lab for this week, go ahead and submit your name where it tells you can submit stuff. I think it's going to be on the right side of your screen. While you're doing that, I'll go and talk about what we're going to be doing tonight. You've already got the handout for Wireshark, which is a network protocol analyzer. And I've actually got it running on the overhead and live connection, capturing packets. And we'll play with that tonight and talk about what it is and how network administrators use it, how network security folks use it. And so anybody else not get a handout? And so we'll be talking about that tonight, and it's very useful for monitoring traffic as well as internally, as well as maybe an IP address that you don't notice that's not in your range, that's on your network. That's also a red flag. And so we'll talk about some uses where you can find rogue access points, maybe rogue IP addresses, things of that nature. And I believe we talked last week a little bit about rogue access points and how that's, in my estimation, one of the number one security concerns in small, medium, and large businesses alike, where folks bring in a rogue access point into their cubicle, plug it in an open Ethernet port, and they now have Wi-Fi connection where anybody can get in, especially if they have the password null, to where anybody can connect to it. So we'll talk about how you can use this tool to capture items like that might be a little odd and a little weird. So anyway, first of all, let's go over the handout. In the first part of it, I want to read a little bit of this. Not in detail, I'm just going to highlight some of the components of it. So the first paragraph talks about understanding network protocols can often be greatly deepened by seeing protocols in action. So it's one thing to know a protocol, like say a protocol TCP, UDP, but to see it in action, meaning see it do something actively in your network, is another thing. It's kind of like telling somebody how a ribeye steak tastes that's never tasted one before. Okay? You can tell them fairly well, but until they've actually tasted one, they're not going to really know what it tastes like. Okay? Same thing with everything you learn in network security or anything in general. We hear terminologies when we're learning things, and we read stories, and we hear about stories about whatever it is we're learning, but until we actually experience it or see it, it's hard to kind of put two and two together on how this works. So that's what this tool is going to help you do. You put together those protocols, and playing around with them is what we're going to be doing tonight. We're going to be, as it says there in the first sentence, we're going to be playing around with protocols, observing the sequence of messages exchanged between two protocol entities. We'll delve down into the details of protocol operation and causing protocols to perform certain actions, and then observe these actions and their consequences. This can be done in simulated scenarios or real network environment, like we're doing tonight. Wireshark, in the Wireshark labs, you'll be doing this course. You'll be running various network applications in different scenarios using your own computer. Because when we do the man-in-the-middle attack, we use Wireshark there to kind of see the activity, how you can kind of capture a man-in-the-middle, how it looks on Wireshark. You can also do Wireshark on a friend's computer at home or at work with permission of IT. You observe network protocols in your computer in action, interacting and exchanging messages with protocol entities executing elsewhere on the internet. Thus, you and your computer will be an integral part of live labs. So the first lab we're going to be doing is capturing the observation is all it is. The basic tool in the third paragraph says, the basic tool between messages exchanged between protocols is called packet sniffing. And packet sniffing is looking at the network traffic and sniffing that traffic and breaking it apart into tiny particles. Those particles make up protocols. UDP, FTP, TCP, IP, just to name a few. Okay? So it's sniffing the network, figuring out the makeup of the packets on each IP address, and then breaking it up into those protocols. Now with Wireshark, you can actually limit what protocols you want to see. We'll play around with that tonight and see if you can figure that out. Also, by default, when you download Wireshark, which is a free program, by the way, you can do it at home or anywhere. When you download it, by default, it's going to give you everything, the kitchen sink, as far as protocols that you'll view. And then you can narrow that down to, say you're only interested in TCP protocol, UDP protocol, or IP protocol, or maybe you don't want FTP in your environment, so you want to monitor FTP protocol, okay? So just to name a few. Another protocol that you might want to monitor in environments would be like SMTP. Hackers like to set up rogue email servers within your environment. The purpose of that is to send mail from your actual network to their email without being recognized. A lot of times the way they do that is piggybacking off valid STP information that anybody can command prompt and find within your network. And those are called MX records, where MX records give you feedback such as your SMTP server. With an SMTP server in hand, I can actually program my code to use that SMTP server as my email server. Most SMTP servers in businesses, believe it or not, are open. There's portions of it that are open to be used by anything. And the reason for that is a lot of applications today internally use SMTP to send messages back and forth between each other, between each program. So there are valid uses for it. So this program can kind of let you narrow down SMTP traffic and say, that's not our SMTP server. Why is all this traffic coming from this suddenly? So that's just an example of the way I've used it. Skip to the second page. Back. There's a diagram which kind of shows you how packet sniffers work. So you've got basically the network coming from your computer through Ethernet going into the network. What you're seeing here is basically a breakdown of an IP into different protocols. The protocols, let's say, would be HTTP, FTP, TCP, UDP, DNS, and IP. Well, they have what's called frames in every IP packet, and it's broken up into a couple things. One is the first part is what the part the packet sniffer grabs it needs a packet analyzer. The packet analyzer that we're using is Wireshark. It used to be called Ethereal. That's why it's, you'll see Ethereal around too in documents about packet sniffers. They changed the name a few years back to Wireshark. So you get your packet analyzer. It captures a packet. Now, one thing you'll notice when we fire this up tonight, you have to grab the NIC card. Some computers have more than one NIC card. So you have to grab the NIC card on that you want to monitor traffic from. Make sure that NIC card is connected to the Ethernet on your computer, and then you're good to go. So once you capture that NIC card, then it goes in and it grabs all the information about that network traffic. The TCP UDP, which is a transport layer, network layer, IP, link layer, Ethernet, and physical layer of the OSI model of network protocols. Scrolling on down. So we'll be using Wireshark, as always mentioned. I don't need to read all that. We can read that later if you want to. Getting Wireshark is very easy to do. There's a download in our course for this week, or you can just go to wireshark.org, or just Google Wireshark. It'll be the first link. The new version that's in this handout, or the version that's in this handout, I believe is the version behind or something, so we might see a little bit differences. But I'll play with it with you on the overhead here in just a second. But I want to kind of go over some screenshots here. The startup screen of Wireshark looks like this right here. And let me go ahead and blow it up just a little bit more if I could, so we can see it. Okay, so you'll notice on the left side where it says interface. Does everybody see that? Where it says interface on the left side. Basically what it is, and I do like this feature with Ethereal, is a little bit, I just used Ethereal for years and so I knew how to use it, but a new student coming in or a person coming in, this one's fairly intuitive, a lot more intuitive than Ethereal. So when you first come in, capture. You got capture, files, these means things you've done recently, website information like user guide, security, how to capture. They have a real nice tutorials for you. I recommend going over those, you going over these on your own. Tons of information on that, on different tricks you can do to capture data. Because we're going to just go over the basics tonight of how to get into it and play with it. But the first thing you'll do is basically click on the capture interface. It'll pop up, it's actually this one right here where it says it looks like a NIC card. Capture options, you click on capture options, you can select the interface or the NIC card. Now your computer's at home, no big deal, it'll have one NIC card more than likely. But in here we've had two NIC cards on most computers. So you just have to connect the right one. You know you connected the wrong one in here if there's no traffic, okay? You'll notice that real quick. But I'll do it with you on the overhead in a second, and everybody should be okay, because I believe the naming of the NIC cards are pretty much the same in here, as far as the two separate. I definitely recommend the website to go to, wireshark.org, for more information, but you can basically find it all from within the first screen of the initial Wireshark launch. So I'm going to go over some screens here on the PDF, and then we'll get going on it. So basically, the interface, the way it's broke down is, you've got command menus here, which everybody's familiar with, like Word, Excel, PowerPoint, any document, any program that you've ever been in. They've got different commands. These commands are mainly on the front page of the interface, but they also have the old school menus. They also have shortcuts you can use that you can learn. So whatever you find easiest. Filter options. Filter options is where you would be helpful to read the tutorials, because they go into multiple filter options of where you can know commands real quickly to filter, say, UDP, to filter SMTP, things of that nature, or filter three protocols at once, or filter a range of IP addresses, and that's it. Okay? By default, it's going to filter everything that your NIC card's connected to by default, and that's what we're going to play with tonight. But there's different commands you can learn to limit the capture. And then you'll notice going down on the left here, the next area it talks about is the listing of captured packets here. Okay? These captured packets are just that. It gives you the timestamp. It gives you the source. It gives you the destination IP, source IP, protocol that it is referring to, and any information. When you double click on any one of these lines, it then will break it down into the detail packet of that header information. So in this example here, I clicked on the HTTP protocol, and notice it gives you the get information, which is what website it was currently on at that time, at that IP address capture, the browser that was used, the computer it was used upon, and so this one was Firefox. It looks like in this example, it captured some images or an image, a PNG image. And then down here, if there's a cookie written to the browser that went to this site in your environment, it would give you the cookie information as well. So you can go into detailed information on every one of the protocols, figure out what you want to know about it. The next one down below is a hexadecimal version of the GUI or the ASCII version up here. It's basically a hexadecimal of this here. Okay, all this here is now hexadecimal, and basically it's giving you line by line everything up here, but in hexadecimal format. I very rarely use that. In fact, never use it, just so you know. You'll probably never use that. But the detail package I definitely use all the time. So they have 5 major commands, which I do like about this handout that I want to go over. The 5 major commands of a Wireshark. The command menus are standard pull downs located on the top of the window. Of interest to us tonight, we're going to do file and capture menus. The file menu allows you to save captured packets. So while you're running a capture tonight, right, when you're done, you can save that capture and email it to somebody or save it to a location on your network to view later. That's what I do a lot. I'll run a capture packet from, like, say 9 in the morning till noon. And then I search for, inside that capture packet, certain keywords, maybe certain websites, certain protocols, certain IP addresses, and then I want to grab that information, okay? But once you save the file, you can actually open up a saved packet file and then view it anytime you want to. You can view it at home, you can view it on a mobile device. It's an XML file, basically. You can open up from even a web browser and view that file. The next one is a packet listing window. So the first is command menus. That's the file menu at the top, which is basically all these up here. That's the command menus. Right up here, file, edit, view, go, capture, analyze, statistics, and help. The next is the packet listing window. This displays one-line summary for each packet, which I already went over. I won't go over that again. Breaking down the packet, the protocol, and the information. Then the packet header. That happens when you click on one of the lines. So when I click on one of the lines here, it's going to bring me the detail information. And then packet header detail, packet contents window, gives you all the information of each line, line by line. So I'm going to show you mine real quick. I've already got it running. I'm going to go ahead and stop it so we can kind of see what's happened here. I'll scroll up to the very top when it was begun tonight. Okay, so I started this around 4:26 p.m., exactly 16:26, so 4:26 p.m. is when I started it, and it ended at 4:38. Okay, so let's just play around with this real quick. I'm just going to show you how easy it is, and then we're going to do the labs actually in there you can do on your own, but I want to just kind of quickly show you how to get around it. One nice thing about these columns is you can click on each column and sort it by column. So when you click on it, it's going to give an ASCII sort, alphanumeric sort kind of thing on each one. So Now, you'll notice this one here. Yeah, let's talk about this one. Was anybody in here tonight when I reset the picture router earlier?
Yeah.
Okay. Now, you'll notice a whole bunch of ARP protocols up there. See the ARPs on the overhead? The ARP protocol is what was, in technical terms, pooched in here. Okay? The ARP protocol gets pooched in this lab a lot because we have other classes, like Cisco classes, that are always constantly configuring routers, switches, doing things on a network that a router would say, or a PICS monitor would say, something's going on here, and it's going to stop IP addresses from working and internet from connecting on different machines. And that's what happened tonight. So when I reset the PICS router, you'll notice it was actually broadcasting and resetting all these machines' ARP address. And the ARP address basically, and we'll go over this more in the man-in-the-middle attack, an ARP table in a server, or in this case a PICS router, stores your IP address, your MAC address, to that machine. Okay? If a hacker messes with that, like we're going to do on the man-in-the-middle attack lab in a few weeks, meaning by saying I am IP address whatever and I want to be your IP address, that's messing with the ARP table, okay? And you can easily do that with certain tools. Well, we do it in here when we're changing, connecting to switches, and we're hard coding IP addresses. That's all going into the ARP table constantly. And after a while, the ARP table, in fact, the rules on the PICS router will start locking out machines from getting internet connectivity. And it's a security purpose. It's supposed to do that. So an easy way to fix it is to reset the PICS router. And that's what I did tonight. And so that's why you saw all these ARP connections going to a lot of, in fact, all the computers in here, as you guys connected to it, it was hitting that ARP table over and over and over and over again. And if you actually looked at this case when I did that, one of the switches in here, in fact, the main switch was all green lights for about probably a minute. After the green lights go away, it starts resolution on the ARP tables for each machine in here. And then the green lights go away for you guys to be able to connect. So it's more technical than that, but that's basically what's happening with ARP resolution. And so anyway, I'm going to go, there's a lot of ARPs all the way till 438 looks like. Then it finally began to, everybody started getting connection around then, it sounds like. And so if I wanted to go by, let's say, timestamp, I can do that as well. I do this a lot, by timestamp versus protocol. So say there's a user I know that's doing stuff every day that they shouldn't be doing. I can go by timestamp of when they come in, and we'll say, okay, we'll just use this IP address here, this 172.20028. Somebody in here went to Google, could have been checking your RBC email. We'll just say for kicks tonight that we were not supposed to be going to google.com at all. It's a rule. You would never have that in a business, but we'll say that's our rule. And I know who this person is, and I say, hey, I noticed that 1627 to 1632 you were at google.com doing whatever. What were you there for? So that's just one example, okay? Or I wouldn't go to that person. I would generally go to their boss, and their boss would take care of it. So that's one thing. And there's literally guys on every location. When I mean guys on every location, every place you work, somebody's doing this. Somebody is monitoring traffic, hopefully. If they're not monitoring traffic, they probably need to be monitoring traffic. Even the best places I've seen this happen. In fact, I went to Bible college, okay? You think Bible college would be pretty clean network-wise, right? Well, an example. I'll go and give this example because it's a good example of what I'm talking about. Once a semester, the IT department would scan everybody's computer regardless who they were, okay? Student in the labs, teachers, administration, and they did that like they normally do. They had caught some activity, pornographic activity on a computer, and it was a gentleman who had been there actually 35 years, and he was in student admissions or something like that, He's a great guy, really, really nice guy. It can happen to anybody. But anyway, long story short, they used that log basically. They had to turn it in. It was protocol. They had to turn it in, and then he was basically dismissed and all the good stuff, or bad stuff for him. But that's just an example. Back then they didn't use Wireshark, but they used some packet sniffer to actually figure out his activity. That's what triggered them, because they would do random checks too if they found peaks in, say, pornographic sites or whatever. Because it's normal for somebody to maybe stumble once on a pornographic site in any business or any location, and then you go away. You can see that in the activity. It's when they start coming back for hours on end that might be an issue. Okay, you're generally not going to trail every single pornographic website that somebody hits, because again, you can search anything. We've all done it. You can Google Jesus and get pornographic websites. Whatever. And so somebody can click on a link and get it. So. And we've all done it. Close a browser and go about your business. It's when you see the activity progressive, and it is. I guess this is where it's subjective to you as an IT department, or a rule or something. You can say a rule of this many times they hit the site, any pornographic site, this many times of this length of time, we're going to turn it in. You have to decide what that might be for your area. I've seen that everything from every instance to if they're on it for more than 5 minutes, if they're on it for more than 2 minutes, whatever, whatever your time frame is. And so it again is subjective, and that would actually probably be a protocol to look around your region, talk to people you work with, your CEO, COO, about this very topic, and get their feedback as well, what they think. Because they might just say, no, I want every instance, regardless what your reasoning will be for that, how asinine that would be, they might want that, okay? And after a week or two of them getting every instance, they might come back and go, now what were you saying about, okay? So, you just do what they want, and then it'll basically come back to what you wanted, probably, if you're patient. So I go by time usually, but then also you can go by IP address. If I know I want to look at certain IP traffic of whatever, just click on source, and again it gives me a nice top-down view of every IP address in here and what websites they went to. So let me scroll down real quick till I actually start seeing some activity here. Okay. Now, I don't know what these sites are, so I'm just going to go for it. All right, so this site here, craniumcafe.com at 1627, somebody went to. Who went to that site? craniumcafe.com? Nobody? I can find out. I don't care. I'll keep going. Instructor GitHub. Okay, here we go. Canvas badges. No, we don't want to do that. Let's go to the info page. It'd be quicker that way. If we want to find websites anyway. That won't pick on anybody. It's going to be down in this view a little bit more. I was going way too fast. These can scroll very quickly too. Okay, stop. There we go. That's what I want to see. DNS. DNS protocol is websites, dynamic websites, domain name translation, and it's a protocol of a domain name that's been typed in. And that's the protocol that is grabbing right here every site that people went to in here tonight while this was running. And a lot of, RBC Eagle, a lot of screen, there's mine actually right there. That's the one I went to, Screencast-O-Matic, to log in for recording purposes. So Twitter's on here, so you can go through all of them. And so if you have a list of sites and say you only want to see certain protocols, you can then, this is how I do it anyway, you can basically filter it I can go up here and say, I just want to filter, let's see, HTTP, apply it. This will give me my HTTP activity. If I want to filter anything else, let's go with browser. This is the type of browser information, TCP, and then if I want to clear it and bring all of them in, and then do the protocol this way, go ahead and go up. Down at the bottom, I think. So there's all my DNS protocols. And you can actually just store DNS or capture DNS stuff if you wanted to. Now let me do this. I'm going to click on one of these. Let's click on any one of these. I'll click on, let's go with, I'm going to pick on Cranium Cafe again. Okay, Cranium Cafe. Came in at this time, September 5th at 1627. Gives me the IP address it came from. So I have destination, source, both. And so this would be MAC address. So if it was spoofed or whatever, you could grab it from the MAC address. Internet protocol will give you IP address information. This 172.20028 is a local IP address that went to the site. That's the IP address, the destination of the website. This goes into different information down here on the query of the domain, and you can break it down even further of the host if there's any information there of interest. Let me see if I can find any flags in here. Nothing really. And so it looks like a valid site. Nothing. Say they want it's okay to go there, whatever. So I'm breaking down one line though in this example. Breaking down one line only, but I can also do other protocols too. Say if I want up here to another protocol, say let's go to, let's say, go up to the top here, TCP protocol. Okay. Here actually, some of your protocols actually will give you data as well, especially if they downloaded a file. So if they downloaded a file, you could get protocol and TCP information. Here's a UDP one. Data is what I was wanting. Okay. So this is actual data. This is basically just hitting the website. It's going to grab data. But one of the cool things with this is if you find one of these that somebody downloaded a file, or maybe they downloaded a text file, you can actually capture. This will capture that text file as well that you can view in that packet. Generally, it's going to be in the TCP packet. It's going to be able to find that. So let's go ahead and flip to your handout to where the lab starts. It's not a real long lab, but there's some things I want you to do, and then I'm going to tell you how to do it, and then what I need you to turn in. So if you flip to the page, it says taking Wireshark for a test. Taking Wireshark for a test page. So the best way to learn about any new piece of software is to try it out. We'll assume your computer's connected to the internet via wired Ethernet. And so this is the page actually you should be on right here. So it says to start your favorite web browser, and we can do Chrome or whatever is fine. Start up Wireshark. You'll begin the packets. It tells you exactly how to do it, selecting the capture pull down. I'll show you how I do it. It's a little different maybe than what they show you. It's a little quicker though. You'll then see a list of interfaces. You'll click Start. Once the packets begin on step 5, you'll see a window that I just showed you. Begin capturing the pull down, then select Stop. and you'll see what happened. You go through the HTTP protocol, which would be the web browsing protocol. So, and then it talks about going to a certain site, which this site I did not check before class. We'll see here. Yeah, it does go. It does. This site actually downloads a file you'll be able to see in your protocols when you go through it. So let me show you how I start mine, then you guys can go for it, and then I'll let you read it and go through it. Now, when you get through all the way through number 10 and you exit Wireshark, all I need you to submit to me is, for tonight anyway, is the name in the lab. You're not going to do what to hand in. You're just going to do the name protocol. Now, what they have in this little lab to do is not a bad lab to do. We're just not going to do it in class. It is something you could do on your own, though, if you wanted to. It would be good, because you're going to take this whole handout with you. So let me go ahead and show you the way I do Wireshark. Okay, I'm going to go ahead and quit without saving. You guys should have Wireshark in your start menu, hopefully, or on your desktop. But if you don't have it on your desktop, just go to Start, All Programs, Wireshark. Does everybody not have it? Okay, as soon as you start Wireshark, on the left side, where it says Interface List, if you double click on the interface list or just click once, you'll notice on mine it says Intel and MS Tunnel. MS Tunnel is what they use for the Cisco lab to configure the switches. You don't want that one. Okay, in the handout it tells you to just click the Start button, but let me just quickly show you what Options does here. Options, if I click on it, and you don't have to do it, you can just watch me, I could actually capture, say I just wanted IP information, or if I just wanted TCP port HTTP information, I could actually just collect that. And everything else, basically, I would always leave as is. But there is times I will tell what to capture. Also, I will tell at times on the file what to browse, what connection I want this to be saved to when it's done. So all you do is click on the interface and click Start. And when you hit Start, it should begin capturing. But the handout tells you before you do that to go to a website of any website you want to go to. So I'll go, like, say for this one, I'll go to facebook.com. I'll go to that one. And I'm going to go ahead and clear my packets. And make sure I got the right interface. Start it. I want to continue without saving. It's going to clear it. And I'm just starting up right now. I'll go to Facebook and do a refresh or whatever. In fact, let's just, for fun, we'll go ahead and type in, I'll go ahead and log into Facebook. How's that? And you guys can go to Facebook or wherever you want to do while it's running. I want you to do something, though, and then once you capture it, go ahead and do the Stop button, and then that's when you'll be able to see the protocols that's talked about in the handout. Okay, all the protocols. And specifically for this one, we're going to go for the web browsing protocol, or the DNS protocol, actually, so I can see Facebook, the Facebook information I went to. Okay, so go ahead and start with number 1 on taking this test, Wireshark for test run, and do exactly what it tells you. And I'll be around helping you, or you can help each other as well. And by the way, that PDF file that I handed out to you is in our, I believe it's in our week 3, because I don't remember how long that URL is that you have to type in. I don't remember. I think it's kind of an ugly URL, but that's not too bad, I guess. I was going to say, if you wanted to download that PDF, you could actually click on it from within the PDF while Wireshark's running. And on number 9, it has you go to the get information, which you can see stuff, but the one that you're going to really see information is the this one here that says HTTP, and then it says text/HTML. That's going to actually give you data at the very bottom, I believe, on your line base. It's capturing the actual file information from the HTML code, basically, the HTML page. If you wanted to play around with other sites, you can do that. It's not going to take you real long to do it. And we're going to talk about some other things you can filter here in a second. I always have students do this during this lab because it's not going to take you real long. You can actually work with somebody and have that other person go to whatever website. You can have them, go to I don't know, MSN.com, read some news articles, or maybe better yet, go to like download.com or log into Twitter or Facebook, and you're capturing this activity while they're working, and then you stop your capture and see if you can capture data that they were going to, websites they were going to, things of that information. Now you will need to find out their IP address, and I'll go ahead and put up on the board how to do that. If you don't know how to do that already, I'll put up on the board how to do it on XP, which is basically the same on all machines. You'll hit the start button, type in CMD, hit the enter key. Then you're going to go ahead and type in, this is for your computer to find out its IP address of that computer. ipconfig is really all you need. You can do an ipconfig all, but ipconfig will give you your IP address that you can give your neighbor to see if they can filter your IP address traffic. Okay? If you wanted to do that, you may do that real quick, since we do have time, if you want to play with that real quick.
With this lab here, do you want us to just save a capture file?
Well, actually, if you don't want to work with what I just mentioned with your neighbor, you could actually do some other stuff, like it has on the lab hand-in, what to hand in. I'm not going to have you hand in. You can do that. But really where you're going to find out most traffic is if you do what I just told you to do, have your neighbor go to a whole bunch of websites, capture their IP address, and see what they've done.
I was curious if you wanted us to hand any of this in.
No, you don't need to hand any. Nope, definitely not. Nope.
Yeah, cool.
Okay, I'm going to work with you. Don't mind. You want to give me your IP address? I'll go ahead and do yours real quick. And I'll give you mine as well. Okay, what's your IP address? Okay.
What's the fit? Is it like IP equals and then the IP address? Is that how you filter the IP address?
Yeah, there's actually an IP filter you can do on there. 172.200.28. Or you can just click on the source and destination columns too and do it that way. 172.200.28. Okay? Yeah, if you go to the filter, actually, there's actually an IP address selection, and I can type in his IP address, which I'm going to do. Copy that. Drop down there. It's ip.addr equals, and then the IP address. Yeah, if you click on this drop down next to filter, it should be in one of the selections for you.
Oh, okay. No, there's nothing in mine.
Okay, I'll put it up on the board. I mean, you don't have to do it that way. You can just capture everything, but.
If you start typing like IP.A,
Yeah, it should. You're right. IP dot. Just do IP dot, and you'll see it. It'll do an IntelliSense for you. And I'm going to do some stuff for my person here. I'm going to go on Facebook and just start browsing stuff. And
The get is
I'm going And it's best to do the filter actually after the packet's been ran, after the thing's ran. You can go up there and filter it after that too. Yeah.
Go ahead and refresh your page again.
If you wanted to download a file from download.com and not install it, you can do that as well. You will see a peak in traffic when you are downloading a file.
I don't know how they get away with that, free download all over the place, people are trying to get stuff.
Oh yeah. Yeah, you saw mine peak actually when I did that. Mine's what, 2? I think mine's 2.8. What site? Oh, you're going to MLB.com? You download them. Why don't you try to go to like Twitter.com or maybe go to download.com. Do something like that. Trying to think. Yeah, go to download.com or whatever, where you can actually download a file. In fact, you can be even on any website and download a picture. I should be able to see that content downloaded that you downloaded from the website. You can even be on MLB.com, I believe. You should be able to do that.
There it is. Fine. Just took a few minutes. Okay, now I got some.
What other sites you go to? Have you done anything on it yet?
Just now.
Okay.
Are you filtering by IP address or are you doing?
Yeah, on his I am. Yeah, I'm filtering his. He went to MLB. He's going to download.com right now.
I'm not seeing a whole lot from him.
Well, you're not going to a lot of times.
Okay.
That's why I said it's probably best to.
Clear. Maybe just filter by HTTP.
Yep. Yeah, because I believe it's going to filter IP traffic only, web browser traffic. Okay, go ahead and stop your packet capturing and we'll see what we find for your neighbor if you haven't already done that.
Dot 6, I believe. Yeah, 20.0.6. Wait. I see all kinds of stuff for me. Facebook or something, see if this is on. Start my browser.
Well, yeah, it's never in the first day. Yeah, it's never in the first day, but everything.
You probably got a lot on mine. You get a lot on mine.
And he still has to turn it back. I'm already done reading it. I want to he only does like one week.
Here's the instruction key.
Yeah, it makes sense. Yeah, first one. Chapter 5. I read that. Tuesdays.
So you're saying, when you just filter by IP, sometimes you can see all.
Yeah, you're not going to see all the protocols. Okay. Did everybody get a chance to play with this a little bit with your neighbor? All right, let's look on the overhead real quick on some of the stuff I found on just stuff people website downloaded. And the easy way to find out what people download or access on a web browser in your organization, if you filter by the info column and look for any Git commands, it will usually say TCP out of order. And this is where you're going to find out actual file paths to pictures or text. Like here's a PNG file. There's a software download information. Let's go up a little higher on this one. And what this red means actually for this protocol here is it means it's out of order, and it generally means it was maybe 5 or 6 browser sessions on one computer downloading files at the same time. And let me clear this out and go by Git again. And let's go to the, here we go. Okay, so if you're looking specifically for downloads here, tons of information. To find actual text information, you look for in this Git column on the right the word text in the actual information, downloaded information. And sometimes this will give you data as well. Okay, let's go up here a little bit. This looks like a sponsored ad on a website. Yeah, Google Ads. Same thing here, I'm guessing. This talks about all the different types of cookies that are being saved. And so with this tool, and again, you can search by, the way I recommend using it is do a general query, run it, and then after you've run it and saved it, then you can go in and query it with the commands at the top. You can query by IP range with the ip.addr. At the end of your results, this is what I do. At the end of your results, you can actually go in here and do a save as and save that capture file, all packets, or if I want to select a certain packet or range, I generally just do all so I can go later and look at it. I'm going to quickly just save this one to my desktop. I'm saving this to my desktop, and then I'm going to go ahead and close out of Wireshark, open. Just go to File, Open, so you can see it here. Search by details, sort by details. There's that test cap. It's around 9 megs. I open it up. It's opening up that cap file, and here I can go ahead and begin doing whatever I want to as far as investigation goes. Okay? So that's Wireshark. Definitely recommend it. Download it, play with it. Yes?
Just a quick, for instance, practical application of this. Obviously, in a setup of 100 computers in a business, you can sit there and be looking at this.
No, not all day. No, I save it.
So what kind
When it goes by, you wouldn't be able to see anything.
yeah.
Mhm.
I guess I'm trying to figure out why somebody would be looking at this in real time.
Oh, you wouldn't be. I never look at it in real time. I run it for like 6 hours, save it, and then I filter it.
So what's
For certain
the
activity.
trigger that would cause somebody to go back and look at it?
Trigger, it's a protocol, a daily protocol in IT, to where we have to look at log files like this every day. And we search for certain IP addresses, certain websites, certain protocols, FTP protocol, maybe SMTP protocol, TCP protocol. We generally search for stuff like that. And then we look for activity that's weird activity. It only literally takes me probably about 5 minutes to go through a 6-hour log, knowing the filter. I have saved filters, because if you notice when you go up here and start doing stuff in the filter, it saves what you've done.
Right.
So I have 20 filters I go through and can filter whatever. And then there has been times, at least once or twice a week, where I find stuff like an IP address that was from a rogue access point, as an example, a couple weeks ago. A person was FTPing to a website. They're not supposed to use FTP in that location, even though there's some users that can. This one user wasn't, and I could tell by the IP address of their machine. So that's just a couple examples of protocols that this could be used at in practical ways. All right? So, because there's always going to be people in a 100-people organization that are always going to be doing stuff they aren't supposed to be doing. And so this just helps you kind of, yeah.
I'm trying to envision, by okay, somehow, I mean, like you go to a corporation, okay, the VA,
Right.
I mean, my God, a 5-minute draw,
Oh, yeah.
a 5-minute thing here is going to be.
Yeah, and then you can filter, though. I have captures. I filter by capture what I want to filter. Like, I want to filter just an IP range for an hour or 2 hours or 6 hours or whatever, and it runs for that long period of time. And you can have different instances of this running. So I can start up Wireshark 5 or 6 times on a computer and have all 6 of those running different captures.
Yeah, but somebody's still got to read it from
Yeah.
what I'm understanding.
Oh yeah, you definitely have to read it. You definitely have to go through, and most organizations have a person or persons that actually, that one of their jobs is going through filter. Like here at campus, from 4 a.m. to 7 a.m., we have somebody go through our log of the prior day. Of every filter that's saved data, they have certain protocols of things they search for, and it takes them about 2.5, 3 hours to go through that. If it has to do with child pornography, they find that there's protocols for that. If there's websites they download, that there's protocols for. So for every organization, you're going to have certain protocols that your filter might not capture and block. And that's what this tool is going to be good for. Does that make sense?
Yeah, I mean, it makes sense. I'm just,
Yeah.
it seems still strikes me as an insane waste of time.
Well, it's not really, because I can see if you thought you're just sitting here watching for 6 hours, but literally I start it, 6 hours later it stopped, it automatically saves that file. I spend 5 minutes doing my queries, done. So I literally am spending 10 minutes maybe the whole time. Does that make sense? So it's not that long of a time. Once you start using it, it's not that long of a time. But I can see from what your perspective is, how you would think you just sit there and watch. You don't do that. No, that would be totally asinine to do that.
Just filter for
Yeah.
certain things.
Yeah, exactly.
You're looking for what your other automatic stuff wouldn't have.
Exactly. Like here on campus, we filter very little, right, on campus. There are stuff we do filter, or web filter out through Barracuda, but by law, we have to now, like child pornography has to be filtered out. But even there are some instances, I will tell you, not exact instances here on campus have happened, but there have been instances in the last semester that half a dozen to a dozen folks were hauled off for child pornography because they were caught. And that one actually, there's triggers that the guy has set on his computer, the IT person has set. He can be at home, and when it captures that keyword or whatever he has set up in that, it texts him immediately the IP address where it's found, and then he calls the help desk who contacts security, and they go right to that computer. They literally be there within a minute and a half from the time it's captured. That's the protocol that they have. And so that's one of the ways we use it here on campus. Other businesses might not use it that extensively because they have Barracuda tied down like Fort Knox basically. So you might not be able to might not need to use it. Businesses that don't have a tight filter though, I have known that use it for rogue access points. They said they've caught a lot for that. So you can type in your IP range, anything that's outside that IP range. Because if you notice if you play around with it a little bit, you can do a lot of and or statements, which can be confusing. And or statements can be confusing. But you can do like an and or statement that has, you want to show only IP addresses that are outside of an IP range. And that's it. And then you go through that and figure out where they come from. You can figure out what ports they were on, all that good stuff. Even you can narrow it down to even what port they plugged in their laptop to, if you have it set up right. And so again, it's a manual process. It is something, once you learn it, real easy to use though. Very easy to use. You just have to practice with it. Yeah. So what do you guys think? More investigation for sure, right? Read up on it, download it. They do have a portable version of this, by the way, that I do recommend. If you go to portableapps.com, I was going to mention this next week, but I'll go and mention it now because I use this a lot. Portableapps.com has what's called a suite that you can download to a Windows USB. And what it does is it has in there, OpenOffice is in that suite, and OpenOffice lets you, edit, Word, access, PowerPoint files, edit and create. But it also has security tools in there you can find. One of the tools you can find as a portable tool is Wireshark, portable Wireshark. And you basically just put in the root of your USB drive and it runs from executable. And that's a really good tool to have. And so all these tools, they actually have, I'll mention it next week, it's about 100 meg download. I'll take it back, it's even bigger than that. But anyway, once it's unpackaged, it's quite large, but it has a whole bunch of security tools in it that are run off a USB portable drive. And so it just runs off a portable drive, and you can, I actually have it zipped together, and I will basically give you guys that on a CD next week to where you can put it on your USB drive. And it has like, hundreds and hundreds of security apps that all run off of a portable drive. One of them is Wireshark, the other one has a portable antivirus software that can do a scan, portable ESIS, which basically is another kind of thing like Wireshark, but it's a graphical interface where it kind of looks like a weather radar map, and you see the dots of your IP addresses in your area, in your network, and then when you can set it up to where when IP addresses spike, meaning they download a file over, say, 10 megs, it alerts you via text message or email. So I'll show you guys that next week. It's pretty cool. And it's totally free. The tools I'm mentioning are all totally free to download. So Take the handout with you. Make sure before you leave that you have put your name in the lab folder, and take your badge with you. I think everybody successfully logged into that. So, and if you want to play around with this app or help me test it, let me know, and in a couple of weeks I'll give it to you on your iPad. It's iPad only right now. I'll let you guys test it with me.
Next class.
Do what now?
Doing these like-
Yeah. If you have me in other classes, that will work for your other classes. Yep. It'll work for all my classes. It's the same ID basically I use in all of them.
That Security Plus software,
Yes.
were you gonna bring that in?
Yeah, I just got everybody's name last week.
Oh, okay.
I sent off everybody's name, and then we're going to be sending me back some information.
All right, cool.
So if you send me information, I've got it.
All right, thanks.
Yeah, go